Namaskar my dear friends. Let's continue with the LTSpice simulations. So what we will do is we will do voltage analysis in this particular sessions. So basically we will take some circuits and we'll try to identify what is the voltage at different nodes. Okay. So let us say we have one circuit which is having one voltage source and there are three resistors R1, R2, R3, and we'll be trying to identify what is the voltage at place V1, what is the voltage at place V2, and similar to that we will also try to identify what is the current across these resistors as well as what is the power dissipation across each of them, and we will try to take some different circuits as well to find out different voltage nodes, right? So we'll try to find out voltage at different resistors, current through each of them, power through each of them. So voltage, current and power we will do with different circuits as well. Okay, so this is going to be very basic circuit as well as this will help you to understand your voltage division principles as well as voltage analysis in a particular circuit with simulations, right? So you will be able to see what is your input voltage at this particular point, what is your voltage at different places, let's say V1 at this point and V2 at this point. Okay, so what we can do is let's open a circuit in LTSpice. So once you open, you can try and design this particular circuit. Otherwise what we will do for you is we will take up a new circuit. It will be easy for you to understand. Okay, so let me take a new circuit which is draft2.asc. you can see. Okay, now to place a voltage source, what we will put? V. So voltage source is done, right? Now place R. So R resistor. Now to rotate this, control R I can use, so I can rotate it, right? So R1, let's say R2, let's say R3. Okay, now we need one ground, so we can put G. So for that it will be a ground, correct? Now what we will do is we will quickly wire this up. So to wire this up, this is the wire. Okay, this is the pencil kind of thing which can wire the circuit. So you can put this wiring very easily. Okay, it has moved this way, so I'll just delete that. Now let us do this wiring quickly. Wiring of these resistors are done. Okay, now what we'll do is we'll try to put the values of each of the voltage source as well as the resistors. So what we'll do is let us right click on this voltage source. Once you right click, see this is the hand symbol that is coming on this particular component, right? So right click, you will get the option of putting the voltage value. So DC voltage, let us say I am going to put 12 volt. Okay, press OK, then it will take 12 volt. Okay, now change the values of each of the resistors like R1, R2, R3. So let us say I am going to put 1 kilo ohm, this one I am going to put 2 kilo ohm, and this one, third one, as you can see there is a hand symbol. Put right click to change the value of this. So you can change the value of this to, let's say, 3 kilo ohm. Okay, now I am going to run this. So let me first remove all the other circuits. Okay, good. Once you press this particular run symbol or otherwise go to this simulate and there is run. Okay, if you don't see this particular toolboxes or these icons, then you can go to simulate and run. Okay, so once you run this, it will ask you to do the transient analysis and what is the stop time, what is the time to start saving data. So stop time, let us say I want to stop my simulation after 1 millisecond. So I am going to put 1 M. Okay, then I want to save the data from 0 time, like I want to save data from beginning itself. Okay, so you can see you have a transient operation code here. Now press OK so that your transient analysis has started, right? Now as I told you, if you place here this probe, then you will see your voltage probe and you will see this is 12 volt green color. But the problem that will happen is I'll put voltage probe at this between R1 and R2 and between R2 and R3, like that. If I put, the voltage nodes will be V001, V002, like that. Okay, so what is the problem that we will face? We will see that we are not able to identify which voltage is for what node. Okay, So that's the reason. Very good thing is you have to label the nets. It will be easy for you to understand, right? So what I'm going to do is I'm going to put this label net and I'm going to put V in for the input voltage. Okay. So V in, just make sure that it touches the net. Okay, touches the wire. So it touches. Now I'm going to put the name for these as well. Okay. Since these are V in, I'm just going to right click and change the name to V1, and here also I'm going to change the name to V2. Okay. So between R1 and R2, the voltage between R1 and R2 is V1 and R2 and R3 is V2. Correct? Now let's rerun again. So voltage, input voltage is 12 volt. Okay. So you can see V in is 12 volt. Now what is the voltage after this R1? So you can see this is 3K plus 2K, that is 5K. So it should give you 10 volt, right? Because 10 volt will be the drop across these two resistors. 2 voltage will be drop across this manually, right? So if I place here, I am going to see V input 1 as 10 volt. You can see this is 10 volt, right? Coming back to see to V2, V2 will be how much? 3 to the 6 volt, right? So you can see the red color which is going to come as V of V2, that is 6 volt. Okay. Now let us try to identify what is the current across these particular resistors. All the three resistors are in series, so it will be easy to identify very quickly. The current through this resistors will be V by R, that is going to be 12 by 6, that is 2 milliamperes, right? So to see the current, come across the component and you can see there is a arrow across this, right? So once you see, you can see the arrow is from right to left. Okay. So it will give you a negative value because current is flowing from this direction to this direction, right? From left to right. But I am going to measure the current from right to left. So it will give you negative value, as you can see, little bit greenish color. This is like little bluish color. Okay. So this is minus 2 milliamps. Okay. Actually minus 2 milliamps will be current for each of the resistors, R2, R3, each one of them. So there is no change, right? So you can see the legends are I of R1, I of R2, I of R3, and this is how you are going to get minus 2 milliamps, right? So we have seen voltage at these nodes and current across any of the resistors. Now let us say I want to find out what is the power dissipation across this resistor. Okay. So power is what? Basically power is V is equal to P is equal to V into I, that is voltage across R1 multiplied by current across R1, right? So this is the understanding. So you know voltage across R1 according to the calculation will be 2 volt multiplied by current will be how much? 2 milliamps. So that is total 4 milliwatt. So this is the understanding that we should have, right? So once you open the circuit, now what to measure the power in this particular circuit, what you have to do is, as you come over this particular component, you have to press Alt, then it will change the symbol. As you can see, Alt, then symbol change, right? So you press Alt on your computer tab, Alt, it changes the symbol, and just click it. So there will be a change which is going to come V of V1 comma V in multiplied by IR1. Okay. So you can see this is going to give you 4 milliwatt. You can see this is 4 milliwatt, right? So basically it is telling you that voltage of V1 minus V in, V in minus V1, right? V in is later, right? So V in minus V1, that is voltage across R1 multiplied by current across R1, right? Similar to that, power across R2 will be Alt, then it changes the symbol. So you can see this is dark blue color, this one. So this is going to give you 8 milliwatt. Okay. Similar to that, power across R3 will be this, which is going to be give you 12 milliwatt. So basically based into resistors and current across this. So 3 into 2, that is how much? The voltage across this is 6 volt into 2, that is 12 milliwatt, right? So you have understood all these things. What you can do is, let us quickly change the value of DC voltage to 6 volt and check what is the difference that is we are going to get. So as you can see, the current across this R1, R2, R3 will be changed to 1 milliamps. Okay. Now let us say we have lot of waveforms in this particular waveform window. So we want to see only the V1 value, right? So double click on this, only V1 value will come up. Okay, double click on this, only one value will be seen in the waveform window. So you can see only one value is seen in the waveform window, which is 5 volt, right? If you want to see V2, just double click or double click this, only 3 voltage coming across this, which is V2. This is my input voltage is 6 volt, right? Input voltage 6 volt, right? Now let us just do the little bit complex in this particular circuit. So what I'll do is I'll just press copy and select this circuit, okay, and this has come out. All right, now I'll just take a new circuit. It will be easy for me to quickly make a change. Now let me delete some of the or let me add 2 more resistors. So place R and I'm going to put resistors like this, okay, R4 and R5. Just connect these two. So we are going to make the circuit little bit more complex so that you can have a different understanding, right? So let me tell, this is also, or let's say this is 10K and this is also, let us say 20K and let's say this is going to be 10 volt. Now we have we have V1, V2, current across R5, current across R6, R5, R4 and R3, all will be different. Now let's run this particular circuit. Okay, so this is our circuit of interest. Now what is the voltage V in? So as you can see, this is 10 volt. Now what is the voltage at V1? So as you can see, it is calculated to 7.6 volts. So if you want, you can do the voltage analysis and check this. Coming to V2, which is going to come up as V2, which is red color, that is coming to just more than 4.2 volt. Okay, now let us see what is the current across this particular R5. So that is going to come up as 0.2 ampere, 0.2 ampere. Okay, and across R4 is going to be IR4. You can see the name IR4, that is going to be 750 microamperes. Okay, so this is how you can analyze your different values. Okay, the understanding is I have run this particular circuit for 1 millisecond. If you are not able to see your voltage, current or something, you have to always go into simulate and see edit simulation command and change the stop time up to what you want to run it. So let us say I want to run it for 10 millisecond, so it will save the data for 10 millisecond. Okay, so I have changed it to 10 millisecond. Let's rerun this particular circuit. So it will change the axis to 10 millisecond. Okay, so it helps you to understand this kind of particular understanding for sinusoidal waveform of inputs or maybe pulse waveform of inputs or something like that. So hope you have a very good understanding about a basic circuit of voltage analysis and see what is the difference between how to connect different resistors and see what is the difference in the voltage drops, right? So let me quickly delete some of the values. Let us say I will delete all of them. Okay, now what is going to come is I have just 2 resistors, one is 1 kilo ohm and one is 10 kilo ohm. So let's say I'm going to make this also as 5 kilo ohm. Okay, so do you agree that my voltage V1 will be twice of this across this R1, right? So basically this is going to be how much? Around 6.5 volt or something. Let's say I am going to make this 12 volt. So V1 will come calculated as 8 volt, right? So let me rerun this. Now as you can see, I am just going to click only V in, which is going to be 12 volt. What will be the V1? V1 will be 8 volt. Current across this will be how much? 12 by 10 plus 5, 15. So it will be just less than 1 milliampere. So you can see across this particular R4 just less than 1 milliampere, which is 0.8 milliamps, right? If you want to see power, what you should do? over this particular component, what is the power dissipated? Alt this power change, right? So you can see power is 6.4 milliwatts, right? So alright guys, hope you have now a good understanding about this particular thing. Now if you want to see like all the node voltage and everything, that we'll see in our next session. Thank you so much.